Have you ever heard of nylon polymers?
I get asked that all the time when I tell them I'm in plastics. Have you seen The Graduate?
I'm sorry I brought that up.
It's okay.
That's pretty pedestrian
No, it's
comedy
okay.
right there.
It's fine. It's fine. I get it all the time. I'm used to it.
In this episode, we're going to talk about material selection. You ready?
Yeah, I'm ready.
All right. So let's talk about what the part must do in real use, including loads, wear, heat, and environment, and how if somebody came to you and said, hey, I have a widget, what do I make it out of? How do you start that conversation?
Ask a million questions. What's it going to do? What's the application? Where's it going to be? What's it going to be subjected to environmentally, chemically?
One that's come up in this is the part going to be hidden, and can it have a little bit of cosmetic imperfections, I guess?
Sure. Yeah. I mean, all the above. We're asking those questions because you've got 1,000 different materials that you can choose from, and it all depends on what that part is going to be subjected to in congruence with the design. So
right.
You're looking at it from both directions.
And so we're also looking at it from the way it behaves in the mold, how it flows, how it shrinks, warpage.
Yeah. So when you cut a tool, you have to specify what material you're going to run it out of at the time of manufacturing. So, and that's because most materials shrink differently. So you've got some materials. I just had one the other day that it shrank 0.2% inch over inch, and the tooling manufacturer actually came back and said, are you sure? Because it's so uncommon that materials don't shrink that much. So
that notion is a little flexible in that you can make changes to your formulations as long as you don't go off the base raw material?
Yeah, so as long as you're staying in material groups, so you've got like the polyolefins, the polyethylene, you've got polyethylene, polypropylene, you've got nylons, acetals, you've got these specific groups of materials that all have similar shrinkage. And so if you stay within those groups, you're fine. You can
the George Costanza.
You can change them in and out.
Yeah.
But
and folks, we are going to cover some of these materials. I'm not going to cover them in depth in a podcast because everybody that's listening to this is likely to have a different need. Now, we will cover a little bit more in depth polyethylene, polypropylene.
Most of the reasons you can't change these is all dimensional. So if your dimensions don't matter for whatever reason, you're making a plate that maybe if it's a half inch smaller, that doesn't matter. It's not fitting into something, then you can run the gambit.
Not part of a larger family, not under any kind of industry specs.
Yeah, but like your parts, if I was to go we've tried this, if we're going to go from a polypropylene to an ABS just doesn't shrink as much as polypropylene, so you'd have a bigger part.
And how does that affect the run process as far as coming in and out of the mold? Because I know this is where a little dangerous, because I know just enough to be not fully aware. The tool opens up, an automated arm comes down, suction cups onto the part. As soon as the gates close, that part starts cooling. Part of the process that I had to learn was the timing of that automated arm coming out of the machine, traveling to the conveyor belt, tilting to lower onto the conveyor belt, and then, as we found out on some of our parts, the length of the conveyor belt, because these things continue to basically shrink and cool over several hours.
Right. Yeah, not to correct you, but the cooling process actually starts inside of the tool, but it continues. I've seen parts shrink for over 24 hours. And
if you put them in a box, that could also
that holds heat.
Lengthen that time.
The whole goal is to just pull heat out of that part. If you can pull all that heat out by the time it gets in the box, you're going to be in a really good spot.
But you couldn't like dunk it in water.
Yeah, I've seen it.
Okay.
Yeah, water baths. I've seen it.
Golly, I can't imagine all this time that I've spent in the factory, I haven't seen that, and I can't imagine adding that to the mix.
Yeah, we've had parts that are over an inch thick, which is not conducive to
It doesn't sound
molding.
that big.
Yeah, it's huge. Some would say too big. It's a fine line. You don't want parts to cool too quickly. You'll hear some people talk about shocking the plastic, and it just. Well, have you seen those those videos where you take like a hot metal ball and just dunk it in.
Right.
That's all, and you see all that energy popping off that hot ball. You don't want that to happen in plastic, because then in turn comes warp and internal stress. And then you got a bad part.
Hot ball.
Mm-hmm.
All right. Let's talk about choosing material that is not super exotic, more of a commodity where you're not going to have issues with supply chains and things like that.
Mm-hmm.
I can't imagine that's huge, but if somebody was really wanting to do something special, that could come into play.
Yeah, supply not so much, but price is where it's really going to, I mean, you've got some parts that Elon Musk rockets going up. And so it's not so much that you're not going to be able to get it supplied. It's just you're going to be
Paying for it.
Yeah, we talked about that perfect part. You could probably create a perfect part with all the materials out there, but it's going to cost more than an Escalade the size of their coffee cups.
And it's my understanding that some materials are going to have a higher wear on your tool. So if you make a tool and run polypropylene, it could last several million shots. If you're running something that's glass filled, it's going to be less.
Yep, and you can build your tool accordingly.
Which makes it the tool higher cost.
Yeah, it does. So you can go, you can go to hardened steel. We try to stick around like a P20, which is mild hardened. That's just most cost effective. But you can go up to like H13 stainless steel. And again, you're paying more for the part. But yeah, anytime you have a filler in a material.
Man, if you're using a stainless steel mold, I mean, we've got to be talking aerospace, medical, that kind of stuff.
Yeah, or just like something that has a lot of corrosion in the material. So high glass content, you're going to see some stainless steel in there. Or if it's just something that's super high volume, where you're running, millions a week, you're going to want, because you don't want to, when you got that high volume, you don't want to take that tool out of commission. You take that tool out of commission, you're losing cash flow.
Yeah. How about, and this is something that we have had to, I would think that this was the thing that we spent the most amount of time on, is the trade-off between strength, flexibility, stiffness, and impact resistant. Mm-hmm. And I do want to really pause here and spend time on this particular thing, especially when you're thinking about you're going to have to ship it. If it's for sports or kitchenware that's going to get dropped or something like that, or in our case, being trusted by professional farmers that are going to not be nice to their equipment inherently. You can have something that's super strong, maybe a little stiff.
Right.
Could have something a little bit more flexible, but it's not going to break.
Right. Yeah. I mean, the middle ground there, which is like 90% of my projects recently. It's funny. I was talking to my dad, going back to when he was selling. His was all engineered thermoplastics, and all of my projects right now are just polypropylene. And he remembered hearing 20 years ago, he's like, polypropylene's going to be, you're going to see polypropylene everywhere. And he's like, yeah, but he can't get, you can't hit these mechanical properties on a lot of things. Well, he's seeing it now, because polypropylene is just a great commodity. It's the supply chains there in the United States, overseas. You've got there's polypropylene everywhere in this world as far as production wise. Again, it comes down to the questions that I'm going to ask you about the application. Does it need to flex? Does it need to be rigid? Is it going to have a lot of wear? Are there weight requirements? Does it need to float on water? We've had discussions about that on a couple projects. So all of it comes down to application specificity.
If it's going to be cleaned, what is it going to be cleaned with?
Yeah, chemical. I mean, you name it. You go to a playground, talking about sun exposure. You go to a playground, all that's going to be polyethylene, polypropylene.
I was also surprised to learn that you could do things like add zinc, for instance, to the mix in very low quantities, and that plays a big difference in how that polypropylene is going to act over the course of its life.
Yeah, I mean, zinc is antimicrobial. It's got antimicrobial properties. So, I mean, when you start talking about fillers and additives in plastics, it's truly endless of what you can do. We've got a couple suppliers that I've brought them some crazy asks, and most of the time they'll figure it out. So, I mean, smells. We've done that, like rat deterrent based on smells.
So I know, and I like to get anecdotal here just so people can hear the things that, the inside conversations we've had over the years. At one point you had a part, and it was for the pet industry, and it was a chew toy for a pup, if I remember correctly. And
ingestible.
There was, yeah, man. And when you hear that, it's like this. So you're having your dogs ingest plastic.
Yeah, it's not plastic.
Talk us through that.
Yeah,
and then talk us through the outcome that would affect the employees during this process.
Yeah, good or bad, I don't know. Yeah, it depends on the person. Yeah, we had a project where we were injection molding basically pork. I mean, it was dried, extruded pork.
Man, that sounds horrible.
Yeah, well, it made the entire plant smell like bacon. So it wasn't the worst thing in the world. A lot of the biodegradable stuff that we're working on right now makes it smell like popcorn. But yeah, going back to the specific example, you've got to be really careful when you do stuff like that and not call it plastic. Everybody assumes injection molding is plastic.
Right.
You know, you can injection mold a few different things that aren't considered plastic, and we're actually working on a project right now, kind of behind the scenes, that we have to actually market this material as not plastic. It's a plastic alternative that's being injection molded. Looks like plastic, feels like plastic, acts like plastic, not plastic.
So we've also talked about some temperature and like UV things for playground equipment, that kind of thing. Like what heat tolerances, because polypropylene is what I'm used to for our products, and I know that the melt point is
400.
And if something's exposed all day long, you're going to lose color if it's outside.
Yeah.
We do have a thinner product that people tend to leave in a warehouse or a storage container, and sometimes there'll be a warping issue. Not that there's anything wrong with the product, but they're storing it improperly, but it's still our fault.
Yeah, we talked about heat early on in this section, and you want to pull heat out. Well, if you reheat, I mean, everybody's probably heated a plastic utensil up into in the microwave, whether it be a bowl or a plate, too long, right? I mean, what does it do? It deforms. So if you introduce heat back into the process, you're allowing those molecules to realign. So you're gonna have issues. Again, when you're talking to like playground equipment, it's designed properly and it's got the correct material being used. So you're not gonna hit 400 degrees out on the playground either. So not that you have to hit 400 for that stuff to deform.
But you have to go over what it's normally going to hit.
Right. Again, it all goes back to design and material selection.
So we're going to have a whole chapter where we cover this kind of in depth, but we should at least at this basic level talk about compliance issues. You may be locked in to material.
Yeah.
If you're in food, medicine, something like that, you may be told this is what you have to have because food contact has certain parameters you have to hit.
Yeah, and we'll talk about it in a little bit later point in time, but don't lock yourself in. Okay, because there's so many, again, I'm going to say the word alternatives, that there are very few times where you have to lock into a material and for it to stay there forever.
But you'd have to get a new mold. No, yes.
Not necessarily.
Okay.
No, and I'm talking same family groups, same material, but it's got a brand name for whatever reason. If you go through a custom avenue, you get this stuff custom compounded specifically to hit these specific mechanical properties or chemical resistant properties. You may be locked in there, but if you're just pulling something off the shelf, do not lock yourself in to one thing. It'll save you a lot of money.
So when you say don't get locked in, I'm looking at, we're talking about you've said family, groups of family, and in my mind, polypropylene and polyethylene are separately, but my understanding now is that they're the same. They're within the same family, and they're close enough that they could be used in the same machine. Like kind of basically the materials that 90% of your customers are going to use: polypropylene, polyethylene, polystyrene.
Okay, so you've got different groups of plastics. You've got crystalline versus amorphous, and within those you've got a list of products. So amorphous would be like a polycarbonate. Crystalline, semi-crystalline would be like a polypropylene. When I say don't get locked in, what I mean is don't get locked into a trade name. Don't let somebody specify that you can only use company ABC's polypropylene.
Got it.
Just say, hey, this is a polypropylene. You can get specific as far as like it needs to be copolymer, homopolymer. It needs to be 10% glass filled, 10% talc filled. You can get specific on that side, but don't say I'm going to use company ABC polypropylene. Does that make sense?
Now we're cooking.
Okay.
Yeah.
Because once you do that and that's on your spec sheet, your manufacturer's going to say, we can't use any other material except for company ABC. And if they've got an alternative out there that's going to be 20 cents cheaper, they can't use it. Now they can come to you and ask. I do that all the time. But whenever we're building spec sheets, I never want to put that specific company material name on that spec sheet. Otherwise, it locks you in.
It's good to know.
Yeah.
And look, this is exactly why people need a sales rep that's well versed, so that they can walk you through these hurdles. Because again, everybody's product is going to be different. I'm gonna say a list of some of the very common ones that we're going to use, and just briefly we'll discuss why this is so popular, or why in a use case in which you would use that.
An application.
Yep.
Yeah.
ABS, balanced strength and appearance, forgiving process, very common.
Yeah, enclosures, something that you need really good dimensional stability on. So we use all of our trays. They need to be flat, right? So if you want something that's going to be dimensional, and you've got to hit your specs, it's also got really good mechanical properties as far as like impact strength. It's got good hardness too, so fairly scratch resistant.
For each one of these, I'm going to ask you for an example. If I were to walk into a big box store and I was going to buy something that was going to be made out of ABS, what would that be?
Electrical enclosures. If
just two general homeowners were going shopping for the weekend and they walked into any big box store, let's just say more of a retail establishment, what would ABS be made out of?
ABS, retail, toys.
Toys, totes maybe?
Totes are polypropylene.
Okay.
But yeah, toys, a lot of toys. I mean, think about it, they're getting thrown around. Like I said, they've got really good impact resistance. If you want a good toy, think of like a toy car, RC car, like a remote control car.
Got it.
The body of that vehicle would be ABS.
Okay. Polyethylene, HDPE, tough, moisture resistant, good impact, limited stiffness.
Totes, lids.
Trash cans, your big trash cans, cheap. Polyethylene's cheap. That's why people love it. Nylon, strong, wear resistant, moisture sensitive, higher processing care.
Yeah, a lot of like bearings and gears that you'd see internally. Talk about the cars again, probably those internal gears and bearings that are going to be inside.
A lot of times on those non-exposed parts, that's that kind of milky, yellowy kind of plastic.
Yeah, and then you've got, you're thinking like clothing. There's a lot of nylons in clothing. I know we're going outside the injection molding area there, but a lot of clothing is nylon. Textile.
Reminds me of The Graduate. Have you ever heard of nylon polymers?
I get asked that all the time when I tell them I'm in plastics. Have you seen The Graduate?
I'm sorry I brought that up.
It's okay.
That's pretty pedestrian.
No, it's
comedy
okay.
right there.
It's fine. It's fine. I get it all the time. I'm used to it.
Acetal?
Acetal. Same thing. Very, very close to nylon.
Let me re-ask it. Is that how I was asking how you said it?
So it's actually funny. A lot of people say acetal. A lot of people say acetal, and they're wrong.
Dude, I would have never guessed that.
But I hear acetal a lot.
And for those of you wondering, we are in East Texas. And I'm not from here, but I have developed this twang over the years. Don't like it.
Acetal is going to be very close to nylons. You see that interchange quite a bit. Where I've seen it, and I know we're talking about big box stores, acetal's kind of hard to pick something out that you're going to see in a retail situation. It's going to be more industrial. So think about those modular conveyor belts.
The description I have is low friction, dimensionally stable, and good for moving parts.
Yeah.
Would that be like internal
Gears, bearings.
shut-off valves for like water?
Yeah,
Okay.
yeah, that's exactly what it would be.
TPE, soft rubber-like feel, over molding friendly.
Yep, soft touch. So think phone cases or.
Something you would use after hours?
Yeah.
Okay. Somebody's got to make it all, you know what I mean? Glass-filled nylon, high stiffness and strength. Maybe that should be made out of the other one.
Yeah.
High stiffness and strength, more tooling wear.
Yep, more tooling wear. A lot of gun parts. You're going to see glass-filled nylon.
Stocks.
Yep, stocks. Mags. You're going to see some decently high glass-filled nylons on that. I've seen as upwards of as much as 60% glass-filled nylons in those types of applications. So the glass makes it look cool too. I think that's why a lot of times people add glass. Not only does it...
It's a real smooth feel, right?
Yeah, you can't feel the glass. Sure. Now if you put your hand in the material, the raw material, you'll feel it.
It's going to be a bad day.
Yeah, it doesn't feel good. Don't put your hands on your face after you do that.
Or anything else.
Not talking from experience, but it does make it look cool. So it kind of you get more of a matte. It's like a matte shiny combo.
Material-filled polypropylene improves stiffness and stability. That's the zinc additives that we would talk about, or other compounds that you could do.
Yeah, usually glass is where you see this. You see this in a ton of automotive parts. It's got incredible properties for impact. So it's like that. It's like a cheaper ABS, basically. You get similar. In fact, 10% glass-filled propylene has the same shrink as ABS, unfilled. So you'll see that a lot of times where they'll start in ABS, and then when I talked about the finish, that you get that cool industrial finish with the glass, like that matte shiny look, they say ABS is extremely shiny. So it's almost a polished look to it. And in these industrial applications, sometimes they don't like that because it shows a lot of marring and wear. So they'll go to a polypropylene with 10% glass, and it looks cooler and acts the same. They can run it in the same tool.
Right on. So I tried to cover this very high level, very basic, just so people get an idea of kind of where to start as you're talking to your supplier. The next episode, we're going to be talking about some of the alternative materials that are either out or coming out, or things that you're kind of excited about. Mm-hmm. We'll do that next.